Hi, I'm Don Hatfield from Intrepid Control Systems, and I'm presenting the wireless BMS solution from Intrepid Control Systems. Come and see us in this demo at booth 1201 at the battery show. The RAD-WBMS solution is basically the key network tool that you need if you're doing any kind of PV/DV testing or manufacturing testing, functional test, end-of-line test, or recycling, remanufacturing as well. Basically, the RAD-WBMS incorporates the chips from Analog Devices WBMS solution. So you can talk to the people at Analog Devices about the solution itself and what you can do with the specific chips. Basically, this is essentially a replacement for what's called the manager in the WBMS solution from ADI. But the difference between this and, say, a regular development board is that this is entirely productized, and it is also, there's a full API that you can use to control this in a manufacturing environment, as well as complete software like I'm showing here that allows you to make your own testing for any kind of testing validation you might be doing in the lab, or even if you are working on a battery pack and trying to do things like cell balancing, finding certain cells or nodes, groups of cells that are actually faulty or are weaker than other ones, and you would like to replace them, swap them, etc. So basically what you would do in order to communicate with the battery pack, which I'm showing here, is basically you hook it up to your computer, and then you can use all of the commands that ADI has created for the WBMS system, and you can use those same commands within our software to do all the different types of applications. For instance, cell balancing, monitoring the cells, switching the cells into their different modes, and also to even provision the cells for production, so they're completely bonded to the main manager within the battery pack. The WBMS can actually communicate two different ways. It can communicate wirelessly, so you can actually see that there's actually two SMA connectors here. That's how we communicate wirelessly. And in fact, inside of here is not just one manager, it's actually two managers, because there are some applications where we'll put two different managers inside of the same ECU or manager ECU inside the battery pack, because I might have two stacks of cells or two groups of cells to allow me to have double the cells that I would normally have with a certain type of solution or a certain chipset. So I can communicate wirelessly to any of the nodes, and I can also, using this connector here, communicate via isoSPI. Well, isoSPI is the wired communication method that is used for the ADI chips. It's an ADI exclusive protocol. You can use the isoSPI connection to directly communicate wired to a manager. Okay, so for instance, if I needed to service a pack, I could actually use the wired connection to connect up to the manager in a production pack, and I could actually tell it to essentially disconnect from all the nodes inside, and then I can use the wireless to communicate directly to each node, figure out which node is bad, and then I can pull that node, put in a new node, and then rebond them together using the isoSPI wired line. I can also communicate raw isoSPI to other ECUs that happen to have the ADI isoSPI communication protocol as well. So in addition to communicating just to the battery pack, I can communicate to all the other associated ECUs within the battery management system. Allow me to show you one of the examples. This would be something that you might want to do as an example test. And we've created this all in Vehicle SPI, really with just a very small amount of scripting in the background, but mainly using graphical panels and putting in our own graphics for the batteries, all that you see here, and then a total that you see here for the total battery simulation. In this case, we're seeing 60 volts. And that's all being measured wirelessly from this battery simulator, which is it's basically two different pieces. There's actually a node simulator, The node simulator here has two different chips in it. One of the chips is the wireless chip. That's the one that I'm pointing to now. Then this one that's turned 45 degrees is actually the sensor chip. And it's actually measuring the voltages coming from the battery sensor, which is the second piece. And so these are actually development boards from ADI that you would get when you're evaluating the product. We'll talk more about the battery simulators and the node simulators in a second. But basically, you'll see that we're hooked up with VRLA essentially in this graphic to our RAD-WBMS, which I have here. And then I've got my simulators here. Technically, there's only one simulator in this demo. And then we're actually showing the voltages coming from the bank and actually from each individual cell. In this case, there's 12 cells. And if I turn this pot, you'll see that the battery voltages go down each individual cell. And you'll, of course, see the total series voltage go down and up as I turn it as well. And you can do a lot more than just simply monitoring that data. You can build your own test. You can make decisions. You can automate a test all within VRLA. So for all of your PVDV testing, for any kind of validation, for troubleshooting a pack that you're building as part of a captive test fleet, you can really do pretty much anything that you'd want within VRLA using our tool and our GUIs to actually build the test that you need. Okay. Now, there's other applications besides just simply testing. Okay. When you're doing manufacturing, you need to have a tool that's more rugged than these simple boards here in order to test your cells as they come in from the manufacturer. And once you have a node assembled, you'll need to also check the voltages so that you can match up cells because you want them all to be the same voltage. And so that way it simplifies the process of cell balancing. And then once you assemble the pack, you need to have tools that can actually join together the manager ECU with all the different nodes. And so you can also use this tool in a manufacturing process. So as another example, I've went on site with OEMs, connected up to their own nodes in their own battery packs, identified certain nodes that are actually bad or are just a lower voltage than the others so that you can swap them out. And that enables you to assemble those packs and do all of that production work. And you can have that being done by the battery maker as they assemble the nodes. And then when you get the nodes into your manufacturing, your final assembly for your pack, you can then double check them before you put them in, then put them in, double check them, make sure that all of them are communicating, and then finally bond them together. With the ADI system, there is very many levels of cybersecurity to bond them together so that they can only be used with that particular vehicle. Now, I mentioned these boards are actually rather fragile. You really would not want to use these on a bench. You really wouldn't want to use them in a manufacturing situation. So we have fully productized and ruggedized all of these pieces of the solution. So we have the RAD-WBMS, which serves as the manager, which you can fully control through USB or Ethernet. And we have an API for that. And we also have a node simulator. So basically, literally the same board that has those two chips on it is also inside of here, but we put in the automotive power supply and ruggedize and productize it so it can be put into a manufacturing system, or you could easily use this on a bench, or just put the box into your backpack and bring it along with you to either do a demo or demonstrate a problem, communicate with your team, and show where you're at. And then finally, there's a battery simulator, which really goes hand in hand with the node. These two are connected together, and the power comes from the battery simulator. So really, although you can technically get them separately, they're really made to be used together so that you have an actual battery simulator. And you'll even see that there's a potentiometer here at the end, just like this smaller blue board that I'm actually adjusting with now. And all of these are available through Intrepid Control Systems, and we have very deep knowledge of the ADI system. So with all that said, that gives you a lot of different opportunities, a lot of different avenues to help you get your wireless battery management system out into the field and get to making money. Thank you very much for watching. My name is Don Hatfield from Intrepid Control Systems.